All right, good morning, good afternoon, good evening, wherever you are. I hope that you're doing well. Here's what we're going to be talking about today. Yesterday, the day before, we talked about how we had to prove all the corresponding sides and angles congruent in order to have congruent polygons. Well, today what we're going to be, and the next day we actually said, hey, there's some shortcuts to proving these polygons congruent, these triangles specifically, whether it's side, 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 or side, angle, side, okay? Today what we're going to be talking about are two more shortcuts that you could possibly use to prove triangles congruent, okay? So what I'd like you to do is pull out your vocabulary sheet, and I'd like you to jot down the postulate that you see on the screen there, postulate 4.3. It says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent, okay? Now, if you're a highlight type person or you like to box things in, which I definitely am, the key terms right there are the included side, okay? And so as you write that down, just pay attention to the triangles here that I'm going to mark out and see if you understand what I mean by the included side. So what the theorem starts out, or the postulate starts out saying is if two angles and the included side of one triangle. So what we're referring to is the two angles, and when we say included, we're talking about the part between those two other parts. So what side is between these two congruent angles? It'd be that side right there, okay? Are congruent to two angles and the included side of another triangle, the triangles are congruent. Well, that's angle, side, angle, okay? And so, like I said the other day, you can use SSS for side, 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 and SAS for side, angle, side. Well, you can also use ASA for angle, side, angle. And remember, that side has to be between those two congruent angles. That's the key, okay? If I look at the next one, and again, if you need to pause your computer so you can see that, go ahead and do that, okay? The next theorem says this: if two angles and the non-included side, okay, and again, I would probably highlight that, put a box around it, of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the triangles are congruent, okay? So what this one means is this: if those are the two angles that I mark congruent, the non-included side would be the side that's not between those two congruent angles. Well, I could either go here and here, okay, that would be an option, that would be angle, angle, side, or I could go here and here, okay, that would also be angle, angle, side. It's still two angles in the non-included side. So again, the key to this one, if I write the acronym out, angle, angle, side, is that this side is outside of the two congruent angles that we're looking at, okay? So angle, angle, side versus angle, side, angle. Make sure you know the difference between those two, okay? Now, again, if you need that statement up there a little bit longer, go ahead and pause your computer and take a look at that there. Now for this next one, let's see if I can stretch this out. Very good, okay. Now what we're going to do is we're going to look at our notes here and make sure that we understand everything that we just talked about. So, in looking at your notes there, it says, what else must you know to prove the triangle's congruent for the following reasons? So, it's not asking, can you prove the triangle's congruent? It's saying, what else would you have to know in order to prove them congruent? There's a difference there. So the question, the first one is, we've got two angles already congruent, B and C and E and F. Okay, so which side would we have to prove congruent in order to use angle, side, angle? Well, I hope that you're thinking to yourself, that side there and that side there, because it's between the two congruent angles there. So if I put that down, we've got that right there. BC must be congruent to EF. Okay. All right, now the next one is angle, angle, side. Okay, so we've got a pair of angles congruent. Okay, we've got a pair of sides congruent. What other pair of angle? So if I mark this out, I've got this and I've got that. Okay, what other angles would I have to mark congruent in order to have angle, angle, side? Well, it could be these two right here. Oh, those two right there. Okay, so angle G, I could prove that congruent to angle J. All right, and have angle, angle, side. okay? Or, and again, notice it's the side must be outside of these two congruent angles, okay, not included. Or, if I go ahead and erase those two, I could have also used these two angles here. Okay, notice how, again, the side that's marked congruent is not between the two congruent angles. So I could have also used angle GKH and angle JHK. Those could have also been some options there that we could have used. Okay. So, moving on to the last one here. I want to prove these two triangles congruent by angle, side, angle. I've got the pair of vertical angles already marked congruent. Okay. That should be the very first thing you should do in any problem. Okay. The one thing I've tried to stress to you guys is that all proofs have a certain flow to them. They have certain characteristics, and if you see those characteristics, it should, you know, pop out to you right away. Okay. From there, what other angles would I have to prove congruent? Because right now I have an angle and a side. What other angle would I have to prove congruent to use angle, side, angle? Well, if it's angle, side, angle, the side has to be between the two congruent angles. And the only angles that would allow that to happen in the picture here would be angle L and angle P. Okay? Because now the side is bookend by those congruent angles. So, again, angle L must be congruent to angle P. All right? So those are the things I'm looking for. Now we're going to move on to something a little bit more important to prove the two triangles congruent. Okay? We want to ask ourselves, can we prove them congruent? So as we look at numbers 4 through 9 here, okay? Looking at number 4, the two triangles are separate from each other. And the one thing I stressed the other day to you guys was this. If the triangles are separate from each other, they're not attached in any way, then there's nothing else that I can prove about them that isn't already proven. So I look up here and I see I've got right angles, okay? I've got a pair of congruent sides, but I don't have side, 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 angle, side, angle, or angle, angle, side. So as a result, I'm going to put down no conclusion, not enough information. There's just not enough there. Okay, they might be congruent, but we have no idea. Okay. For number 5, I'm probably going to mark down that this segment here, which is shared between the two triangles, has to be congruent to itself. Okay. So TV is congruent to TV. Again, this is one of those things that you need to recognize in all proofs. If a side is shared, congruent to itself by the reflexive property. Now the question then is do we have congruent triangles? And I think you see that we do. By what reason? It's going to be angle, side, angle. Again, it's because it's the side between those two congruent angles. Okay. Now from there, I'm going to put down that STV is congruent to, and take a moment and see if you can figure out the corresponding parts of the other triangle. STV, well, which vertex corresponds with S? That would be U. T, well, that's one congruency mark in this triangle. I have to go over here, one congruency mark in that triangle. U, V, and then we just put the last one down there, T. Okay? All right. Now again, with the congruency statement that we just stated there, guys, you can state it in multiple different ways. Okay, it doesn't matter. The key here is that you do match up the corresponding vertices correctly. All right, number 6. One of the key things that I've tried to stress to you guys over the last couple of weeks is that vertical angles are always congruent. Okay, and so I'm going to put that down right there with the hopes that anytime you see a picture that has adjoining angles like that you will mark it like that you'll mark them congruent. Now, as we look at the two triangles, do we have congruent triangles? The answer is yes. Okay, and in this case, I would know they're congruent by angle, angle, side. Okay. Now, here's the deal. You could have also proven these two triangles congruent in a different way. Let me show you this. If this angle is congruent to this angle, then I would know that this line is parallel to this line, right? I mean, if all interior angles are congruent, lines are going to be parallel, okay? And if that's true, then this angle here would have to be congruent to this angle there, okay? Again, because if lines are parallel, then alternate interior angles are congruent. Okay, so I have the option of saying that these two triangles are congruent by angle, angle, side. Okay, the other way. So it works either way. It just depends on how you want to prove it. I like to do the vertical angles, but maybe someone else would do it differently. So, all right. Now, I write that out. I didn't mean to write the same thing out, even though it was true. Here's what I was thinking. You could have also marked the vertical angles here congruent. And now you have angle, side, angle. That's what I was thinking there. So either of those would be an acceptable way of proving those two triangles congruent. All right, now, from there, the congruency statement. Let me clean this up a little bit. There you go. The congruency statement here for this would be this. Triangle WXY, if you want to start with those three, would be congruent to, now let's think here, W corresponds with A, X corresponds with Z, and then Y. Okay, good. Okay. Now what I would do if I were you from this point is I would probably pause my computer and see if I can do the last three on my own. Okay? See if you can figure out if they're going to be congruent or not. The one you get done, come back and see me. All right, now looking at number 7, I hope you marked out the vertical angles congruent right off the bat. And from there I would know I have congruent triangles by angle, angle, side. Again, notice that the side is not between the two congruent angles over here. So my congruency statement, and again, you could have had something completely different. Let's say you go EBC. If I match up E to B to C, that would be D to F to C. D to F to C. Okay. Oh, I did that wrong, didn't I? EBC would be FDC. There you go. There you go. Okay, so we've got congruent triangles there by angle, angle, side. All right. Number 8, I hope you mark the vertical angles congruent. And as I look up there, there's nothing else I can mark congruent. All right. Now, I want to change this up a little bit just to make sure that we have what we talked about earlier down. So do this for me. As it was marked already, yes, these triangles wouldn't be proven congruent. We don't know for sure. But I'm going to add the fact that those lines are going to be parallel to each other. What does that then mean? Well, I hope you're thinking to yourself that that means that the alternate interior angles have to be congruent. So I can mark those two congruent, or the other pair of alternate interior angles congruent. Well, what would that then mean? The triangles will be congruent by angle, angle, side. Okay? And so as I finish this off, if we go ahead and do HGJ, what would that correspond with from the other triangle? HDJ, KLJ, L, what am I doing here? KLJ, there we go, okay. So, hopefully you got that down. In the last one, you know, they're separate from each other. I've got an angle on the side, an angle on the side, but not enough information there to prove them congruent. So you can go ahead and put down no conclusion and then just not enough information. Okay? All right, I'm going to walk you through the last two proofs here fairly quickly just to make sure you've got these down. And then I'll let you go on your merry way with the homework for tonight. So, looking at the next one here, let's see here, S, R, P, and Q, okay? And we know that angle S is congruent to angle Q, okay? Now the question then becomes, let's look at the diagram first because I think that's the easiest part. Looking at the diagram, do we have enough information to prove the triangle's congruent? Not right now. But what we do have is a segment that's shared, so I can go ahead and say that RP is congruent to RP by the reflexive property. Okay, by the reflexive property, those two segments, or that segment in both triangles, would have to be the same length. Okay. Now, still not enough information, so I'm going to go back to my given, where it says RP bisects angle SRQ. Okay. Now, what you should be thinking at this point is, if you cut in half an angle, the result of that is going to have to be two congruent angles. So I'm going to go ahead and put down this angle here is equal to that angle there. Okay. And so I'm going to put down that angle SRP is congruent to angle QRP. I want to make sure you understand this, hit this home. This segment here, okay, is bisecting this angle here. So the result was that those two angles have to be the same measure. Okay. How did I know that? It's from my understanding of what bisects means. So definition of bisects. Okay. All right. Now from there, do I have congruent triangles? By golly, yes I do. So I'm going to say angle SRP, triangle SRP, is congruent to triangle QRP. What am I doing here? Oh, I misnumbered here. 2, 3, and now 4. Okay, now we're back on track. All right. And the reason? Well, it's going to be angle, side. Okay. So hopefully that made sense to you guys as you work through that. Again, the big focus is bisecting. What does that mean? And you're going to see it come into play on this next theorem or proof as well. All right, last proof. Here we go. We got parallel lines, which are marked out by those red arrows. Okay, and we also know that QR or XR bisects QT. So as I look up here, I think that most of you analyzing the diagram are going to notice the vertical angles to start off with. So I'll go ahead and say, I'll mark them down here. Angle XMQ will have to be congruent to angle RMT. And the reason? Because vertical angles are congruent. Okay, so again, what I talked about before, the sequence, the flow of all proofs, guess what? It comes true again. Okay. Now the next thing, I don't know what you guys will choose to focus in on. It doesn't matter for steps 3 and 4. You can go either way. Let's start with the fact that we have parallel lines. What would have to be true based off the fact that these lines are parallel? What did we talk about last chapter? Well, we said that corresponding angles are congruent. We said that alternate interior angles are congruent. And same side interior angles are supplementary. So which set of angles do we have present in the picture here? Because they're not just going to give us these parallel lines for no reason. Well, we have a pair of alternate interior angles. You can either say angle T is congruent to angle Q, or you can say angle R is congruent to angle X. I'll go ahead and do this right here. Okay. Angle T is congruent to angle Q. Now this next part is important. The order to which you state your justification is important. Did we start with parallel lines, or did we start with alternate interior angles? Well, we started in the given with parallel lines. So which conditional will we use? Is it going to be if alternate interior angles are congruent, then lines are parallel? Or is it going to be if lines are parallel, then alternate interior angles are congruent? And I certainly hope that you went with the second one of those, which, as I said just a moment ago, if lines are parallel, then alternate interior angles are congruent. Okay, have to be congruent. Do we have congruent triangles? Not yet. Okay, so what are we going to do? Well, we are bisecting this segment right here, QT. So what's the result going to be? Well, when we bisected an angle, we had two congruent angles. When we bisected a segment, we have two congruent segments. So if XR, this segment here, cuts in half this segment here, I hope you're thinking this segment has to be congruent to this segment. Okay. So I'm going to put down here for step number 4, QM is congruent to MT, definition of bisects. Okay. Because they cut the segment in half, those two segments have to be congruent. And now as I look up there, I've got congruent triangles. Hallelujah. So I have triangle XMQ is congruent to triangle RMT by angle, side angle, or ASA, as a lot of students would like to say. Okay? All right, so I hope that was understandable. You do have some practice problems online. Make sure you take a look at those. And have a great day. Good night.